Welcome to Between Data and Risk podcast. Today we'll talk about the food industry and the food-related chemical manufacturing with our guest Keith Wolf, Executive Director at one of the global chemical producers. Stay tuned.
If you're a business owner or senior manager, you probably had more than enough about all the wonderful opportunities awaiting you in the era of digitalization.
Whether it is big data, cloud, data science, or whatever buzzword is currently trendy.
If you would like to hear someone dissecting these claims and showing you what it actually takes to improve business processes, you're in the right place.
This is Between Data and Risk, where we discuss real-life examples of what works and what doesn't in the world of business operations.
Hi, I'm your friendly neighborhood data guy, Dr. Marian, and with me is my co-host, Artur Cognition Share Solutions Chief Risk and Strategy Officer.
Hello.
Welcome to this episode of Between Data and Risk. Today we'll take a look at food industry and the food-related chemical manufacturing. With us we have Keith Wolf, Executive Director at one of the global chemical producers, who agreed to share some of his experiences with us. Hello, Keith.
Hello, how are you guys?
Yeah, we are really good. Excited to have you with us. Could you tell us, because we know that there are a lot of myths around food industry, and we would like to debunk some of them and also talk about the specifics of the chemical industry business operations. But I think the topic is so important that before we'll dig into business operations, we would like to ask you as a professional, why do people think that chemicals in food are bad, even though the whole food is just a bunch of chemicals, really? And what good can be done with adding some chemicals to the food?
Yeah, for sure. So you kind of have two ways to look at it. It's food or chemicals or additional chemicals as an ingredient. So the stuff you might see on a label, and then chemicals that are used to clean food systems to be able to operate on clean surfaces. So when you see something on a label, like for example, sodium hexametaphosphate, I think that's probably the most common one people will kind of freak out a little bit about. This is used to kind of develop the structure of certain foods, or it might be used for some sort of a pH sort of need, or a few different things, or to keep your process able to run longer. But I think just in general, when you see a word that is that long, it's easy as a human to assume this is terrifying. And it's not. And like you mentioned, food is chemicals in and of themselves. The air we breathe is also chemicals, and any chemical that's used can, if it's over some sort of a tolerable limit, can affect the body, right? But we're ingesting and breathing in chemicals all the time. So there is a lot of work that goes into, especially food ingredient, to making sure this is safe for the public. There's always something that might be discovered later that might be unhealthy. How many times have we even said eggs are healthy or unhealthy? I know those aren't chemicals, but they are a food ingredient. I feel over the course of my adult lifetime, I've heard eggs are bad or good at least 3 different times. But it is important. So chemicals need to go in there for the structure of the food, to keep the food preserved. I think that's really important. This started with brining and salting things a long time ago in our history. And salt is another could be considered a chemical ingredient. If we put sodium chloride on every label, there'd be some people like, I can't have sodium chloride. Like, well, you put it on your potatoes before you eat it. It's salt, right? Just trying to ease people's minds that. I guess to summarize what I'm saying, there is a lot of professionals that research this their whole life on how to put additional chemistry into food to make food consumable for humans and children and babies. This stuff goes into baby formulas, not SHMP precisely, but there's all kinds of things we need to be able to preserve baby formulas and foods. And that's kind of been a hot topic.
Exactly. So like the old scare about dihydromonoxide, right, being a terrible chemical and
Water.
blamed for everything. Because so it's kind of when you were talking about sodium chloride, I thought maybe one of the ways, and this is I know it's early in the episode to make these kind of suggestions, but maybe we should just name every single chemical instead of these long names. Just call it Bob, and or that nice thing, right? Preserver, and that people will have, because a lot of it is about perception, right? And when you change people's perceptions, it may affect also how they how the market accepts these things. When the chemicals are actually introduced into food, what give us an idea of what kind of process they have to go through in order to be accepted.
Oh, geez. Um, just from a company's perspective, you've got to go through the ringer, I guess, with the government to be able to get it approved. So I mean, it kind of starts with, hey, I want to make this food. Okay, you've got an R&D lab that you're going to try to make the food, and you're going to understand that there's different ingredients that need to go into it to make it do whatever, and then those things are going to be submitted, and the FDA, USDA, these governing bodies are going to look at them and see and approve them. And this isn't something that you know on a Tuesday we could expect to have done on a Thursday, unless you put several years in between those that Tuesday and Thursday. So to it's probably outside of my expertise to detail absolutely everything that goes into it. But any modification, there's always specs that you have to meet, and so any that range of specs has to be approved by the government, more or less, to be able to be ingested by human beings. Or even there, chemicals go into animal feed and stuff like that too. There's times where, if there's some deformed, even just by shape, food, and it needs to go to animal feed, there's regulations around what goes into animals as well. So there's a lot of regulation. Basically, it's really hard to produce a piece of food that's unsafe and it get past everything.
Marian, I think you're on mute. You've been
I've been
playing
lucky
with
to
those
work.
controls again.
I'm a control freak, I had I've been lucky to work with company Reckitt, and I mentioned I think a couple of times that. And I worked with Airwick, and one thing that I remember when I joined them, it was like, everybody wants natural. It was smells, not food. I don't recommend anyone eating or drinking Airwick. But I was asking, why just not make them all natural? And they looked at me like, well, I was crazy or stupid, which I was. And they said, but, there would be such huge amount of allergies and allergic reactions to it. We try to balance between market expectation and safety levels. We are trying to keep essential oils as low as possible because they are just dangerous. So this perception that this artificial chemicals, whatever it means, are bad and natural is good. I fell into it. I was like, okay, let's just make them natural. And they were like, during
And
R&D.
that's where. Sorry, go ahead.
No.
Do you
was
have
just
the same? Do you have the same kind of almost inverse relationship in the food industry?
Oh, for sure. There's, I think the most common thing I hear is, well, I want all organic food, and so I won't stick my foot in my mouth by talking about that too much. But there's policy and guidelines around what can be considered organic, the same as something that's grass fed piece of food or free range. There's guidelines for what that means exactly. And so when people say, well, I really like to eat organic food, I ask, well, where do you get your organic food from? And a lot of times, they're talking about their Saturday town I don't go to them, so the name passes me. But where people, they're farmers market. That's what I'm trying to get. So people are, I like to go to my farmer's market. And I get Jeff's apples, and they taste different and they look different. Well, yeah, of course they do. A chicken's egg that you produce at your house is going to be dramatically different from one that you purchase in the store as well. And so we hear organic. So kind of the same thing I think you're saying with, well, I want all natural. Like, well, okay, but what do you want exactly? So do you want some food that there might be a greater risk for pathogens, right?
Mhm.
So a lot, the food industry is trying to keep pathogens out of their food, and they do a really, really good job of that. And but if you want to present some of that risk, and I'm not saying anything bad about farmers markets, but let's just say I'm eating my own food that I grow. I need to eat it very quickly, and there's some risk that I could make myself sick if I don't prepare it well from that point on. The thing with the food industry and what they're trying to do is put the safest food out to you in the safest packaging. And I think that's really important too, because it's not just the food product, but it's the overall product that you see go to the store. There's a lot of work that goes into making sure that is as safe as possible. So when you want something organic, like you could buy something organic off a store shelf as well, and it's going to be fine. It's going to work out pretty well for you as well. But I think people struggle with differentiating something coming out of the ground in your backyard between what's listed as organic at the store.
If I remember correctly, organic, there is an organization which said, but correct me if I'm wrong, that certifies stuff that is organic. And it's not like they are completely, let's say, chemical free. There is just short list of pesticides that can be used. And these pesticides are actually pretty old, and they need to be used in some ridiculous concentrations. So I'm a biologist by education. I don't think that organic certification means healthy. I don't have a feeling it's exactly the equal sign, but please correct me if I'm wrong. It's
I don't know if I've ever heard of make that claim. So it's the NOP is going to be doing like organic certifications here in the U.S. And you're right. There's a list of things you could have contacting the food now. But I've never, I can't recall them ever saying healthy, and I don't want to upset the NOP and have them come after. So I want to stop there. But they are a good agency to work through, and they do have clear rules. Now, I would say one interesting thing working in the chemical manufacturing world, going into food plants, is the sanitizers that we use are registered as pesticides. So the EPA is largely in control of what can be issued as a sanitizer. And the organic governing bodies, they do have some things. I won't list them all out here. There's not that many that you can use as a sanitizer for like you've ran some stuff, some product, and now you need to clean it. You need to start the next run, so you need to sanitize. And so it's really right there where they kind of step in to say, hey, yeah, you use what you need to get the surfaces clean, but for the final food contact step, it needs to be one of these sort of sanitizers, which are pesticides by definition, just the way the sanitizer works, because they're killing microbes, right? They're killing pathogens. So that's why they're considered a pesticide, among many other things.
I wanted to change the tack a bit, because I think we've upset the organic food people. We've upset quite a lot of groups already. So let's now talk about something serious. About data analytics, because obviously Marian is a data guy, and just to keep him happy, how do you use data analytics to make essentially the food chemicals better and to improve your production?
So just from the relationship we have with the food industry, data is king, right? And we try to utilize more and more data every day, because we're largely staffed by either scientists in some way, shape, or form, or people with the scientific view. And so it becomes difficult to go to food manufacturers and say, well, here's what I think based on my experience. And there's nothing wrong with having experience, but at some point you need to be able to back that up with data. So we do a lot of observation. that turns into recommendations, that turns into plans to improve something in some way, shape, or form. And it can't be licking the finger and putting our finger up there and saying, you should trust me because I am who I am. There's got to be something. And so, yeah, data, we lean heavily on that, especially when you're dealing with, trending something or trying to figure out, mild slips and processing or maybe mild increases in bacterial counts. Sometimes you see real big spike events and you need to be able to recognize that. And then you need to be able to use that data to then look down and see what's changed. Because, from my perspective, chemicals just don't, that have been used for, say, a decade in a process, don't suddenly become ineffective. And I could almost say that with a certainty. If there's a problem, it's probably not the chemicals that have been used in a certain way for a very, very long time. Something else has changed.
So before our technical break, you were mentioning that chemicals don't stop suddenly, working. It's usually some other reason. If you would be so kind as to tell us what can happen that, I'm adding my salt to my soup and it's, salty. And one day I add my salt to my soup and all of a sudden it's not. It's sweet.
There's something wrong with your soup, or you're putting sugar in your soup. Basically, so that's kind of what I was. If you've been doing the same thing and nothing's changed, and then suddenly you have a problem, it's really easy to kind of point towards chemicals, and I think it's just a general reaction. But they're not going to become ineffective overnight, right? There's usually some sort of change that occurs with the process and the product, or food manufacturing has incredibly large pieces of equipment that they process on that have a lot of control measures on them, and all it takes is, say, one temperature probe for becoming faulty and unrecognized to completely ruin several runs of producing food, and it can be quite difficult to track down. I think we were talking about data and stuff, so it's always important to be able to trend things from chemical application to runtime to, are you trying to make a different sort of product? Like when you're talking about your soup, I would almost guarantee you have done something wrong with your soup, and maybe you poured oatmeal instead of soup, but it's probably not that salt, or certainly or you had a salt shaker that you filled full of sugar. For example, years and years ago, I was eating dinner someplace, and a bartender had offered for me to drink an old fashioned drink, and I was like, I've never had one. Sure, it was the saltiest drink I've ever had in my life, and I drank it all, obviously. And then he's like, "What'd you think?" I was like, "This is awful. This is probably the worst thing I've ever drank." And I was like, "It's too salty." He's like, "Salty," and he took a drink out of the straw or whatever from whatever's left, and he's like, "Oh," like that. He's like, he looked at his ingredients, and instead of putting, I think, bitters or something, he had put a kosher salt, something like that. It was the wrong ingredient, and it made the thing awful. But he had no idea until the consumer drank it, right? Because you probably don't want your bartender tasting every drink anyway. But there's always some change that happens, and what we work with food manufacturers on is identifying that. And very rarely is it going to be the process of chemical addition that you've been using for a very, very long time. If somebody thinks it is, they're probably trying to sell you more chemicals, and that's not always necessary. It's more important to find what's happened in the process, than really just any sort of knee-jerk reaction. Sometimes you do need knee-jerk reactions to get something solved quickly, but at least from the organization I work with, people I work with, we really want to solve the problem, and the answer is generally processing, and if nothing's changed, that's where we're going to start.
Actually,
so anyway, data is king.
Very interesting. You mentioned about something really interesting, because we spoke with Markus Konlein some time ago. They produced precision machines, and he said that they work really closely with people who actually use their machines. They're not just producing machines and putting them and do whatever we want with it, because they are high precision machines and they take part in complicated processes. They also work with their clients to improve and to add some data layers, because these machines can use some data that their clients not always have. And I'm really interested to hear that you It's not like you produce chemicals and you just put them on the shelf and there's someone coming, taking them and adding them to the soup. It's really interesting that you work. How do you map the processes? Like, we are in a business of mapping processes. So you sparked our interest greatly. How do you approach mapping the process that you are analyzing? Do your clients let you do it? Because I know that we need to jump through a lot of hoops before anybody opens up enough for us to help them.
Well, I mean, the first step is going to be non-disclosure agreements,
For sure.
and things like that to have access. But there, I can't think of anybody, nor would I say it here. Otherwise, we'd have to black out my face during this podcast. That won't allow us to see, process flow charts and diagrams and things like that. For us, it's equally as important to match up physically what's out there with that diagram. Because even if, say, you're even looking at some sort of a system on a computer screen, these things are designed so your eye can follow things properly. That's not reality out on site, right? And so it's really important for us to know that and to be able to, yes, take this map, but have a really understanding of where all those things actually are. And, we usually start with, we'll have a process flow map or something like that, and we'll have control maps that customers will share. But it's our responsibility, I feel anyway, that we know where every bit of chemical goes in a facility and in a process. That's what we really need to understand first and foremost. And it just so happens when we do that, we also learn a lot about the process flow. But if anybody's ever like, hey, where does this many unit of measure of this chemical go, we should be able to sit there and just immediately say here, 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 and here, and in these amounts and at these frequencies and at this rate. And then maybe we have to do some typing or looking up, and we can say, and here's the trend of all those quantities and additions. Like that's what we want to do and be able to offer to people. Keep our thumb on that stuff. But we do need to know the process flow. Like if there is an issue and a problem, we should already have that piece, but we should also understand that flow to make the product. And to clean the product.
Just so that we can understand your role, do you help customers design or improve those processes, or are you more interested in customers they have the process, but you help them debug kind of what's going on? What's your objective when you're looking at those processes?
Our objective is both those things you just mentioned. We also have a lot of relationships with equipment manufacturers that we bring them in as well. But yeah, we're as far as designing or design modifications, these are things that we're going to be able to observe and speak to, along with the support from equipment manufacturers. So yeah, we want the processes to improve. A lot of times what we're looking at is, or what we're looking at is how to get a system cleaned properly. That's kind of first and foremost, and have it be able to run, product as quickly as possible and as safely as possible. That's what we're working largely with our customers on. Some from time to time that does leak down into the actual processing of the product, and try to lend our support there as well. But first and foremost for us is always going to be the cleaning and sanitizing of equipment efficiently.
You did mention safety, and that kind of leads me to a very interesting area, obviously for me, which is risk. When you look at those processes, and when you think in the context of chemicals, obviously people we not thinking about people's perception, because you obviously have a much better understanding of what those chemicals are actually meant to do, but what is your perception of the main risks that you consider when looking at the process, and how would you classify the main risks that you think about?
So there's a few ways that products could be recalled. One of those is chemical adulteration or something to that effect. So for us, whether it's making sure that we have everything in place to where cleaning chemicals don't get into the process of the food, or any food additives aren't doing something that's going to jeopardize the food safety. So food safety just in general is, the top bill that we have. So, and it's an easy thing to say, with food safety, because everything else does trickle down with that. Whether it's the actual safety of the food or making sure human beings are, being exposed to chemicals, right? So I don't know if that's answering it that well, but yeah, there's always very specific, things in place to prevent as much as possible, up to the point of physical disconnection of chemical systems to a process flow. Most every food process flow, if it doesn't need a chemical ingredient, will be disconnected physically from any sort of chemicals going in, to where it would take, again, a human wanting to be malicious or something, or just ignorant to a process and pouring some chemical, which is not bad.
So thinking about this, so you've got the safety of the product from the kind of intentional design perspective, that you've got the safety of the product from any malicious kind of intervention from anyone. I'm thinking also of you probably have the environmental impact of your production on in your sites as well, right? That's it. How do you consider this?
So yeah, every geography is going to have different things that they expect to be coming through their effluent water from plants, right? So I mean, you have to identify what those standards are. A lot of times, it's a certain pH value, and a lot of food manufacturers will have wastewater treatment plants to treat and try to get solids out. And I'm certainly not a wastewater expert. I'm enough to be dangerous, and I'm a lot to be dangerous, I guess, with wastewater. I leave that up to the people, but yeah, government regulating bodies are going to say what's acceptable to come through the effluent stream. We just got to know, and we got to react. Some places, they'll gauge off of like electrical conductivity or sodium load. Like that's a real big one. They want to prevent as much sodium. They might prefer potassium, for example, over sodium. It's just figuring that out and then moving accordingly.
So in your context, because we speak a lot to our clients and also on this podcast about ESG, right? And it's an acronym that's become a bit of a weird one recently, because everyone we talk to understands those three letters slightly differently. So from your perspective and in your line of work, could you kind of give us an idea how you understand ESG impact of what you do?
I don't think I've heard ESG. What does that even mean? I don't mean to ruin your
environmental, social, and governance.
Oh God, okay, yeah. Well, I'm just bad at acronyms.
These three.
Yeah. So
no, it's a tough one, and I apologize wholeheartedly, but it's various people, everyone is pretty much comfortable environmental. That's okay, we understand it. And then people say, oh, what's social, what's governance? And different people have problems with either of those two. So, give it your best shot.
Yeah, okay. So I'm with you. I'm just terrible at acronyms. For all I knew, that was some chemical that I couldn't put together in my head. Makes sense. So yeah, without going too much into it, I think the conversation always gets the most interesting at that social bit, and I agree. People, take that, different ways. For me, I don't think I'm going to dive into that here. Maybe if we were at a bar having some beers, I might have some thoughts. And I guess I think there's so much conversation to be had around just social programs in general, or just society, that it's always nice. And this isn't what you're asking, I know, but it's always nice to be able to talk to people that think differently or that translate things differently, and still not shout or anything like this, and also be able to, if you do have some strong opinion, be swayed by other people, be open to reason. And I said earlier, being a scientist is quite important. One of the best things as a scientist anybody should have is being wrong. it's always, it's kind of a thrilling thing to be wrong and to be able to say, oh, I was wrong. Awesome. What's the right answer? I don't know if anybody's going to have a boilerplate good answer to that S right in the middle. I certainly don't. I do know, not to speak, I guess, for my organization, but we do talk about these things quite frequently, and I would just refer you to our website if you want to look it up. Yeah, you guys get it. Like I don't want, I do think that all three of those categories do need to be discussed, and I hope there's never a point where we think we've got them all solved, because then I think we're missing something pretty dramatic. I know that doesn't answer your question at all, but
no, we ask these questions exactly for the reasons that you specified. We want to hear people, and we try to create atmosphere where we can discuss. We do not try to force any opinions. We are really, really curious about how different people understand them, and we try to compile some bigger picture in our heads, as much as our small minds can capture bigger picture. But well, hey ho. I would like to steer us to the safer water. I'm sorry, Artur, to cut in, but I see that there are reefs and crocodiles. So let's get
there be dragons.
Down to business. Dirty dragons. Let's get back to business. I had some exposure, very little, but I remember when we spoke with some global chemical manufacturers, there was a discussion about innovation. And the problem in chemical industry at big level was that innovation was pretty slow because stopping the chemical production for even a day or a time. And I worked with some European funding of research projects, and there were like these startups, and we have this amazing technology, and these big chemical dirty factories, they can become so green, they will reduce something by 0.05% or something. And the answer from big companies was, to introduce this technological change that you mentioned, it would take we would have to shut down the production for a couple of days or weeks. Then restarting it's not like an engine that you just press the button and it all goes boom. Restarting it would take us 3 months to have the efficiency, and probably we would observe the changes or ROI we would achieve in 10 to 20 years. Is it still the case that the chemical industry has, at least in your case, has such a volume that introducing these small changes is you need a really good reason to change the process? Or is it much more agile now?
So from my perspective, it's not. I think, you always have planned shutdowns, scheduled shutdowns, and then unplanned shutdowns where you have, usually enormous amounts of stock of what you're doing. Now, when you're talking about chemical manufacturing, from pulling ore out of the ground and burning it, and then making some reaction to get chemical products there, that is a problem. For me personally, that's not something I struggle with. But there are there was a unscheduled shutdown of a main chemical ingredient late last year, and the ripple effects of that were pretty extreme. Fortunately, after the shutdown, they were able to respond very quickly, and they had a lot of supply. So it wasn't too bad. But from my perspective, that's not really been a major concern. And there's a lot of redundancy too in having chemical product. So I think the one thing that one of the few things that have been scary over the last few years was the issues with our railroads here in the U.S. If a railroad shuts down, now you got a problem. But manufacturing, one of our branches shut down for a couple of days.
Okay. So how do you work with innovation? What kind of other avenues do you have for innovating within your space?
Being able to blend specific products quickly and at a higher concentration, if that means anything. So a lot of chemicals that go out there are in liquid form, at least in my world, and they're blended specifically for a certain process, and they're largely water. So we're shipping, quite a bit of water. So if there's ever a way, and we have people that work on this sort of thing constantly to have a more concentrated product, we're shipping less water. I think, from an innovation perspective, that's what we're trying to do, or we're trying to, maybe clean things with, say, enzymes a little more for less of an impact on the environment in most cases. Just different ways to do what we're doing better. I know that's probably not the best answer, but I think most of the conversations I have around innovation are having more concentrated products. Now, the problem with, you could always send powdered products, right? But what's going to happen next? Now you're asking somebody to mix a powder. So if you're used to getting something at 50%, so let's just say take 50% caustic, sodium hydroxide caustic. That's about as high as you're going to get without it being like a slurry and just being nonsense. But you could send powdered versions of that at 98, 99%, or somewhere around there. But now you have to have a human with a knife or something, or some contraption, or a super sack. Just getting some of that dust on you, it's going to burn you pretty quick. Just real quick, we were talking about misconceptions earlier. With chemicals, years ago, there was a person that had told me that sodium hydroxide, liquid 50%, isn't hazardous unless it's hot. It won't hurt you until it's hot. And he had been told that by somebody, similar to what I was doing. Somebody had said this, and I was like, you want to go put your hand in it right now? And he goes, actually, no. For some reason, I feel like that's a terrible idea. I was like, yeah, it's a terrible idea. I go, of course, when things get hot, they're going to be more hazardous just in general, right? 70-degree water isn't as bad as 180-degree water. But anyway, so I'm digressing a little bit. But that was, they're just going back to the misconception thing. Like, no, man, don't do that. That is terrible. And here's why. Don't listen to me. I told you that.
No, I think it would, if you would send it as a powder, I guess getting it, as you mentioned, to back to the liquid form brings whole host of different risks. I remember when people were calculating percentages during my studies, it could be challenging. It's like three numbers you need to calculate, and it was over some of the people's heads. So when
for you biologists, anything that's multiplication is oh my god, where's my calculator?
Multi what?
Exactly.
Yeah.
Okay. I mean, talking about the misconceptions and the various prejudices, it has brought us a very nice round circle around the discussion. I think it was very interesting to hear because as we said in the beginning, it's when people hear chemicals connected to food, it's something at the back of the brain. It switches on and people tend to freak out. So having a frank conversation about it and just hearing that it's all controlled, there's a lot of process, a lot of data going into it. It's I think it should be reassuring. If people wanted to find out more about this, where would you send them? Do you have any kind of go-to resources that people could delve into and get more educated?
Yeah, when you're talking about just food in general, the USDA, if you just go right to that website, they're going to have fantastic information for you. When you're talking about food safety and quality, they're going to hit all those marks. When you're talking about chemicals, you might throw the EPA in there. The website can be a little difficult to navigate, but
as all government websites are.
Yeah, and USDA is not it's not bad. It can have some more pictures, but I think unless you're, I guess one of my messages is there's a lot of regulation here, and there's a lot of people that it's their life's work make sure food and chemical additives into food are of the safest quality. Trust them. There's going to be people who are like, well, I don't trust the government. Well, then I don't know what to tell you. But That's like I feel like you're
there's
going to
no
have a
helping
lot of
some
problems.
people.
Right? And
We spoke about strong opinions. And,
Yep. And at some point you just go, hey, right on. You go, do whatever you want. But like from my perspective, the USDA website is going to be a really, really good place to start. There's various different subscriptions you could get from there, to notify you of product recalls and things like that to kind of keep your thumb on it as best as you want. And even if you have a favorite food, going to their website, I can guarantee you they're going to have a frequently asked questions or a food safety bit to say, hey, here's our programs and what we're trying.
or maybe just keep to liking this food.
Just eat it.
Stick to what you like.
Yeah.
And with that, I think we've if people want to get more educated, obviously they can. If people want to distrust this, hey ho, we can't change everyone's mind. But as always, let's hope it was of use to at least someone.
Thank you for listening.
Also, don't miss the next one, where we'll talk to Alan Gray, Head of Digital Innovation at Agri-Food Systems Lab at Purdue Applied Research Institute and Executive Director at Purdue Dial Ventures.
Subscribe on your favorite podcast platform or visit pda.show to find out more about future episodes and guests. You can also check out Cognition.llc for more information on Cognition Shared Solutions, our services, and other events hosted by us.
For now, it's thank you from myself, Artur and my co-host, your friendly neighborhood data guy, Dr. Marian.
Thank you, and goodbye.